Assalamualaikum warahmatullahi wabarakatuh. So welcome to my YouTube video. So before we start, I would like you to subscribe my channel and like this video. So for today's video, I would like to explain about concentration of solution. We will discuss about concentration of solution. So in this video, I will explain to you about what is solution first. Okay, what is solution and how solution is formed. Second, what is concentration and how do we describe the concentration in mathematics. Okay, and then I will teach you how to calculate concentration of solution. Okay, so ready? So what is solution? Solution is a mixture of solute, okay, of solute or and solvent. So it is a mixture of solute and solvent. The solute might be in the form of solid, liquid or gas. Same as solvent. The solvent might be solid, liquid or gas. So and then when we mix it together, we will form a solution. Okay, there are five types of solution. Okay, the first one is foam. Okay, foam is formed when when we have gas as solute and liquid as solvent mixed together, and then we will form foam. So for example is whipped cream, and then we have what is whipped cream? Okay, so for this example is whipped cream, the one that we eat it with ice cream. Okay, so the solute is gas. So how to infuse gas in this whipped cream is by whip the liquid. Okay, we whip the liquid. So the solvent is heavy cream. So when you whip, okay, using whisk, okay, using this whisk. Okay, when you whip the heavy cream, you will infuse gas in the in between the heavy cream molecules. So, for this whipped cream, where we find the heavy cream? So, heavy cream is the uh, fatty fatty part of our milk. Okay, that has a lot that has high fat concentration. So bila dia bila dia tapis susu tu, kita ambil yang bahagian yang banyak lemak. Okay, yang bahagian tu kita akan jadikan heavy cream. So this heavy cream will be whipped by this whisk. Okay, and then masa kita whip tu in the whipping process, gas dia akan masuklah in between molecule of heavy cream tadi. Okay, so kita akan dapat, we will get the whipped cream. Okay, so second is emulsion. Okay, emulsion is a combination of solute liquid and solvent liquid. Example of emulsion is mayonnaise. Okay, so when we look at our mayonnaise, okay, familiar kan dengan mayonnaise ni kan? Okay, when we look at our mayonnaise, so our solute is egg and solvent is oil. So we blend it together until form this emulsion. Okay, this emulsion. So example kat sini mayonnaise lah, kita ada egg dengan oil, kita blend together and add lah some spice ke apa ke to increase to boost the taste. Kita campur lah benda-benda lain. This is the main ingredient, yeah. So egg and oil, and then we blend it together, so we will get emulsion mayonnaise. Okay, and then third is gel. Okay, gel. So this one we dissolve liquid. Actually the solute is solid and the solvent is liquid to make gel. So for example here we have gelatin. Okay, kalau kita orang kampung biasa guna agar-agar lah. Gelatin ni orang bakeries ke apa ke kan, yang kata yang apa sekarang apa, yang modern society dia banyak guna gelatin. Tapi kita biasa orang kampung guna agar-agar ataupun serbuk agar-agar. Okay, for this one we have gelatin. So our solute is gelatin powder in the form of solid. Okay, and then our solvent is water. Actually, it is a hot water. So, and then this gelatin powder will dissolve in the water. So, kita akan dapat gel macam ni lah. Okay, so this is the example of beef gelatin powder. Sebenarnya gelatin ni kita dapat daripada bone kan? Kita dapat daripada tulang. So, kita ada halal and non-halal, and the halal is come from beef. And the non-halal come from pork. Okay, the bone, from the bone of the beef. Okay, we get the gelatin powder. Okay, and then we have solid salt. Okay, solid salt is when our solute is solid and solvent is solid, and they are mixed together will form solid salt. So for example is cranberry glass. Okay, actually this glass is not made by cranberry. Actually the color mimics the cranberry. Okay, the color itself, but there is no cranberry in this glass. Okay, so it is made from the solute is colloidal gold. So okay, colloidal gold is a gold that that is dissolved in water, forming pink color solution. Okay, gold dissolved in water, forming pink color colloid that we call as colloidal gold. And then we have the solvent is glass that we melt it first, and then we mix it together, and then it will form this cranberry glass. Campur je sebenarnya, cumanya kedua-duanya walaupun gold ni pun solid kan, glass also solid, tapi kita kena kita kena jadikan dia dalam liquid form, and then baru kita boleh mix it together. Okay. Okay, and then I have solid aerosol. The solute is solid, the solvent is gas. So for example, here is smoke. Okay, we are familiar with this one, especially during musim-musim jerbu kan. Kita biasa dengan benda ni. Okay, apa yang ada dalam smoke ni? Actually, the smoke is contain small solid particles yang kita panggil, yang kita jadikan dia sebagai solute. Okay, the solute is small solid particles, and the solvent is the gas. Okay, when we see here, we see the color of smoke is white, or it can turn grey, right? So the color actually is come from the small solid particles. Okay, the color come from the small solid particles and the gas. And then gas, not only the gas here is a mixture of gas. Not only we have carbon dioxide or carbon monoxide, it is a combination of carbon dioxide, carbon monoxide, and we have some oxygen, because depends on what has been burned here. Okay, the gas in the smoke is depends on what is being burning here. Okay, so that is example of solution. We have 5 types. The first one is foam, emulsion, we have gel, solid salt, and solid aerosol. That is all our solution. Okay. So how about concentration? What is the concentration? So the concentration of solution is the amount of solute present in a given quantity of solvent or solution. Okay, we look at this example. I have 2 glass of water and 2 spoon of syrup. Okay, or red coloring. Okay, so for this example, I have same volume of water, but different amount of solute. Okay, one is in a smaller spoon, the other one is in a bigger spoon. Okay, so when I dissolve this solute into our solvent, which is water, I get this one. Okay, you see the red color that come from the small spoon is lighter compared to color come from the bigger spoon. So why? So this is what we call as diluted solution. Diluted in Malay we call it as cair. Okay, solution ni cair. Okay, because it has smaller solute over solvent ratio. Okay, it has smaller solute over solvent ratio. How about the solution in the right? So the solution in the right, we call it as concentrated. Okay, ataupun dalam bahasa Melayu kita panggil pekat. Okay, why? Because it has bigger solute over solvent ratio. Okay, so we see that here uh, the amount of water is same, but the amount of solute is different. Okay, amount of solute is different. This glass on the left has smaller solute, has smaller amount of solute compared to the glass in the right side. Okay. Second example, I have uh, this glass of water. Okay, but both has different volume of water. You see on the left side, the water level is up here, and on the right side is until here. Okay. So when we compare the volume of water in the on the left side is bigger than on the right side, but the amount of solute is same. So when we dissolve the solute, we will get like this. So you see the color on the left side is darker compared to the on the right side. Okay, dia darker kan? Okay, why? Because this is a concentrated solution. This solution is more concentrate compared to the solution on the right, because it has bigger solute over solvent ratio. Okay, this one, it is diluted because it has smaller solute over solvent ratio. Okay. So, how to describe concentration in mathematical form? So, the concentration of solution can be expressed in various ways. Kita ada 5. The first one is molarity, molality, mole fraction, percentage by mass, and percentage by volume. So the one that I will discuss today in this video is only molarity and percentage by mass. We look at the molarity first. So molarity is the number of mole of solute per cubic decimeter or liter of solution. Okay, so the formula to calculate the molarity is molarity capital letter M equals to moles of solute divided by volume of solution. Okay, in dm cube or in liter. Okay, so the unit is molarity is either mole per liter or mole per dm cube, or we call it as molar, that has unit M, capital letter M. Okay, that is molarity. Okay, how about percentage by mass? Okay, for the percentage by mass is defined as the percentage of the mass of solute per mass of solution. So the formula is mass of solute divided by mass of solution times 100. So in this case, the mass of solution the mass of solute and mass of solution must be in the same unit so that we can cancel the unit. So note here, mass of solution is always equals to mass of solute plus mass of solvent. Okay, we look at example 1. Determine the molarity of 55.0 ml of ethanol solution contains 1.77 gram of ethanol. So the question asks us to calculate the molarity. So we know that molarity formula is mole of solute. So our solute here is ethanol divided by volume of solution. Okay, remember the volume of solution in liter. So right now, the volume of solution is given, which is 85 ml. So we just convert it into liter by dividing 1000. So we will get 0.085 liter. And then for the ethanol, does not given in the question. Okay, what is given is a 1.77 gram of ethanol. So we can calculate mole of ethanol from the mass of ethanol. So mole of ethanol is equals to 1.77 grams times. So 1 mole ethanol is equals to 46 grams. Okay, so we get mole of ethanol, so we cancel the unit gram, so leave for us unit mole. So 1.77 divided by 46, we get 0.0385 mole. Okay, so right now we have calculated the number of mole of ethanol. So we can calculate the molarity. So the molarity is equals to 0.0385 mole divided by 0.085 liter. Okay, so we will get 0.085. So 0.45 molar. This is our answer. Okay. And then we go to the example 2. A sample of 0.892 gram of potassium chloride is dissolved in 54.362 gram of water. So what is the percentage by mass of potassium chloride in the solution? So the question asks us about percentage by mass. So we know that percentage by mass is mass of solute. Our solute is potassium chloride. So mass of potassium chloride divided by mass solution times 100. So right now, mass of potassium chloride is given 0.0892 gram. Okay, this one is given 0.892 gram. But mass of solution is not given in the question. So we need to determine the mass of solution first. So mass of solution is equals to mass of solute plus mass of solvent. So right now our solute is KCl. So given mass of KCl is 0.892 gram plus our solvent is water. And then given mass of solvent is 54.362 0.362 gram. So we can calculate mass of solution. So mass of solution is 0.892 plus 54.362 equals to 55.254 gram. Okay, and then for the percentage by weight, we know the mass of KCl is 0.892 gram divided by 55.254 gram times 100. So make sure the unit of mass of solute is same as the unit of mass of solution, so that we can cancel the unit gram. Okay, so the answer is 0.892 divided by 55.254 is equals to times 100 is equals to 1.61%. Okay, this is your answer. Okay, so this is the exercise. I have give you the final answer. Calculate the molarity of a solution of 1.71 sucrose dissolved in 500 ml of water, and the answer is 0.01. So show the calculation to get the final answer. And then 2, a solution is made by dissolving 4.2 gram of sodium chloride in 100 gram of water. And then calculate the mass percent of sodium chloride in the solution. So the answer there is 4%. So make sure you show the calculation. So I think that's all for my video today. So I hope that this video help you to understand what is the concentration of solution and how to calculate the molarity and percentage by mass. Assalamualaikum warahmatullahi wabarakatuh. Bye.